For this problem, we want to find the equivalent resistance of this mess of resistors. So the way we're going to basically do this is we're going to try and break it down into series and parallel resistors. So my definition of a resistor in series is where the output of one resistor, so like the current's going this way, the output of one resistor is the input of the next resistor. That would make them in series. Now, parallel is where they share a common input and a common output. So for this one, like I said, the current's going this way, they would have a common input for their current, and then their output currents both come together down there, so they would be in parallel. And I don't actually know the currents are going that way, but even if they're flipped, the logic and reasoning would still hold up. So that is what I mean by parallel or series. So when I would analyze this, I'd basically just start from the low-hanging fruit, just look at things that are obviously, well, that I can identify as in series or parallel. So up here, this corner is going to be series. So I'm going to start by drawing, let's label these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That is many resistors. So we're going to have, see here, and we have a branch that comes off, and we have, this is 1 and 2. When they come together, that's going to be 2 plus 2, which is going to be 4. 2 plus 2 equals 4. And right here, that's resistor 1, 2. I should write that just R1, 2. There we go. Pow. Which is going to be confusing because now it's going to look like R12. But you're going to see where I'm going. All right. And that's going to be in parallel with, do it like this, R4, which it happens to also be 4 ohms. Okay? And then we're going to do this branch right here, which is just 4. And this branch up here connects to these two. So we have 2 more in series, 3 and 6. So this would be R3, 6. And they're both 2, so they become 4. And that's in parallel with R5, which also happens to be 4. Yes. And then down here in the bottom, we have just a 4 ohm resistor. And these all come together. So this branch right there comes down to here because it connects at this point right there. Yes. And then this branch also connects to there. Okay. Am I good with that? I think I'm good with that. No. So this part right here doesn't exist. So that is that branch right there. So R1, 2, and R4 right here only connects to there. There we go. That's correct. So now we have that branch. Okay, so now we're going to do this branch right here. So it's going to come down. It's going to go to a 2 ohm resistor. And then it's going to come, then it's going to do, that's crazy. All right, we're going to come back to this branch. We're going to do this branch right here, which is R8, which I think is another 2. Yep, it is. So we have a 2 here, and then this branch is the same as well, which is a 5. And these both go directly back to the battery. Yes. There we go. I know, it looks like a complete mess, and it is, but we're going to get through this. Confidence. So now we had this R4. This is our 2 ohm up here. Make this one more obviously the 2 right there. So for this, let's see, this 4 ohm has 2 branches. One is this one right here. So we have an R2 and an R1, which becomes R3. And then the other branch is a 3 ohm resistor. And these are in parallel. And then they come together to the output of this 2 ohm right here. So these are connected then. And this 2 ohm connects to a 1 ohm, which then connects to the battery. So over to this way. Okay. Super confusing, but we simplified a few things and we're going to simplify it a little bit more. Now let's look at parallel. So I usually try and do series first. It just tends to be easier, not always. And then I look at parallel. So now I'm going to look at the parallel ones. So a lot of these parallel ones they have the same resistor on top and bottom. So the way you do parallel is 1 over R equivalent equals R over R1 plus 1 over R2. Well, when the 2 resistors are the same, so like 4 ohm and 4 ohm, then the way the math is going to come out is going to be 2 over, if R1 and R2 are the same, 2 over R1. R equivalent is just going to be whatever your resistor is divided by 2. So this is going to be a 2 ohm resistor. So I'm going to redraw this. Hopefully it'll get a bit simpler. So we're going to have a branch coming up here. The 4 ohm is going to become a 2 ohm resistor. Nope, that looked terrible. There we go. Up, 2 ohm, followed by another 2 ohm. And it's going to have a 4 ohm right here. And that's going to be in parallel. And then we're going to have, so 2 ohm, 2 ohm, 4 ohm. This is going to be a 3/2 ohm. 1.5. I'm going to write that as 1.5. I know, it's the same thing. I just think it might be simpler. And this is all in parallel with a 2 ohm resistor, which then goes to a 1 ohm resistor. And this whole mess is in parallel with a 2 ohm and a 5 ohm. There we go, which then goes back to the battery. Whoop. So then that's 1. Okay, we got this. We can totally do this. So this, we're going to redraw this again, because we basically just redraw this a million times, and that's how we're going to approach this. So now, we got the 4 ohm up top. So this is going to be 4 ohm, 2 plus 2. 4 and 4 in parallel, which is going to be 2. So we're going to have a battery. We're going to have a 2 ohm in series with a 1.5. And then we're going to have a, let's see, is that true? Let's look back here real quick. So we have 2 ohm, 2 ohm, 3 ohm, 3 ohm. Yep, the 3 ohms are in parallel. So, yes, we have a 2 ohm. And then a 1 ohm. And then make that bigger. 2 and 5. Okay, so now bring this another step. And then this goes back to the battery. I know, terrible artsmanship. It's okay. So battery, the top 2 and 1.5 is 3.5. Then we have a 2. Then we have that bottom there, I think was 2. Yep, that was 2. 2 and 5. And then we have a 1 right there. Okay? So now we're going to combine the 2.5 and the 2. So 1 over 2 plus 1 over 2.5 equals 1 over R equivalent. So for solving this, we're going to get a common denominator of, I don't know, I think 10. So this would be 5 over 10 plus 4 over 10 equals 9 over 10. Therefore, the equivalent resistance is 10 over 9, or about 1.1. And then we're going to add 1 to that. So that's going to be 10 over 9 plus 1, which is 9 over 9, which is 19 over 9. So we have 19 over 9 in parallel with 2, which is also in parallel with 5. We have a battery like so. Pow! So like this. I think this is where we're at this point. So now we're going to add the reciprocals. So 9 over 19 plus 1 over 2 plus 1 over 5. And this should give us 1 over our equivalent total. So this should be all of them. So if I was a better person, I'd do this in my head. I'm not going to. So I'm going to use Wolfram. So we'll do 1 over 9 over 19 plus 1 over 2 plus 1 over 5. I think that seems reasonable. And we should get an equivalent resistance, which is less than any of these. So then I get about 0.852. So the idea here is ohms. One thing to check here is when you find your equivalent resistances are equivalent, it should be less than any of these by themselves, which is true. So if you look at 19 over 9, that's like 2. You look at 2 over 1, that's like 2. You look at 5, which is like 5. And this is less than any of them. So 0.852 is our equivalent resistance. And so our final circuit, equivalent circuit, looks like this. So we have 50 volts, 0.852. And if you wanted to find the current would be V over R. So the current out of the battery would be about 50 divided by 0.852, which is about 59 amps, which is a lot of amps. But I guess there's a lot of 50 amps is a big deal for some of these. Because if you look at some of the simple parts, like here, we're going to have 10 amps. So we have 50 volts across this resistor right here alone. So that's going to be 10 amps. We're going to have 25 amps across this resistor alone. That's already 35. And so it seems reasonable that we get all the way up to 59 amps. So that's how I approach this problem. Really tough, very complicated, but just to use the idea of which ones are in series. Series have the output of one resistor becomes the input of the next. Or parallel, where you find the equivalent resistance of parallel by adding the reciprocals and then taking the reciprocal of that. My definition of parallel is they both have the same inputs and then they both have the same outputs. So I hope that helped. See you next time.